Right, this is going to be a quick little lesson over 1A number types. So after we go over this, you should be able to do that first co-requisite set of exercises over number types. Right, so first of all, I'm just going to take a few notes on the different types of numbers. So we have natural numbers. And the natural numbers are 1, 2, 3, 4, 5, and so on, etc. And I'll just change my ink color for variety. All right, whole numbers. Now the whole numbers include the natural numbers plus 0. So the only whole number that's not a natural number is 0. Now, if we take the whole numbers, we're going to talk about the integers. So we have 0, 1, 2, 3, 4, 5. Okay, made up of natural numbers and 0 make up the whole numbers. Now, if we add -1, -2, -3, getting smaller in that direction, those are our integers, getting bigger in that direction. Okay, so if you think of a number line and think of all those integers sitting on the number line. So if I get a pen, let me get a black one. We have 0, 1, 2, 3 going in that direction, -1, -2, -3 continuing in that direction. So those are our integers. But then we have the places in between the integers. Okay, so let's just say I talk about, say, this location right here. Whoops. Okay, and we'll just say that that is representing 1 1/3. Okay, now you know you could also represent that 3 times 1 is 3 plus 1 is 4. That's also equal to 4/3. That's a fraction. Okay. You could have a fraction, I don't know, say right here. We'll say that that's a fraction 5/6. You could have a fraction right here. I could say that fraction is -1/2. Okay? So what that is bringing us to is rational numbers. Now, natural numbers, whole numbers, integers are all included within rational numbers, but then we're adding all these other numbers in between that can be written as fractions. So a rational number is any number that can be written or expressed, I'll just put written, or as a fraction. Now let's just say I have the number 2.25. Now this is a terminating decimal. a decimal that stops. It doesn't go on, it ends at 2.25. I could rewrite this as 2 and 25 hundredths. Also, it's 2 and 1/4 if you reduced it. You could also write that as 9/4. Either way, you could just stop at 2 and 25 1/100ths. You can see you can write it as a fraction, therefore it is a rational number. So anytime you see a terminating decimal, you know that it is a rational number. Also, think about a fraction such as 1/3. If you plug it in on your calculator, if you do 1 divided by 3, 1 divided by 3, that is equal to 0.3 with a bar over it because the 3 repeats. This is a repeating decimal. If you have a repeating decimal, in other words a decimal with a bar over it, it has to have a bar over it, it can be written as a fraction. Therefore, it is considered to be a rational number. So repeating decimals and terminating decimals are considered rational. Now, one thing I want to point out, think about the number 0. Because you're going to see this in your homework. If you have 0 divided by 6, that is equal to 0. 0 can be written as a fraction. If I have the fraction, say 7 divided by 0, this does not exist. This is undefined. You cannot divide by 0. 0 on the denominator is undefined. Okay? So to write 0 as a fraction, the 0 is on the numerator. Okay? This right here is undefined. All natural numbers and integers can be written as fractions. Therefore, they are considered to be rational. So, we have natural numbers, whole numbers, integers, rational numbers. The only thing we have missing from there is irrational numbers. So let's say I give you the number x squared. I say x squared equals 2. And you might think to yourself, or I'll ask you, well, how are you going to solve for x there? And someone you may know, well, you take the square root of both sides. Okay? So if you take the square root of both sides, you know x is going to equal plus or minus the square root of 2. Well, what is the square root of 2? Well, on my calculator, if I take the square root of 2, the square root of 2 is equal to 1.414213562. And I'm putting a ... because this does not terminate. And it does not repeat. Square root 2 is an example of an irrational number. Now, a couple other special numbers that you might be familiar with are, for instance, the number pi, which comes from the circle. When you divide the diameter of or the circumference of a circle by the diameter, pi is approximately equal to, and it's going to be 3.141592654. But once again, that number does not terminate and it does not repeat. Pi is an irrational number. There's also a special number e. And on your calculator, if you have a TI-83 or TI-84, you'll notice E is above the division sign, so you'll have to push second function. Second function E, that's another special number, is approximately equal to 2.718281828. We'll be using this when we start dealing with exponential and logarithmic functions. This is another example of an irrational number, okay? These are actually pi and e are transcendental numbers, but you don't need to remember that. For now, you just need to understand the difference between a rational and irrational number, okay? A number that does not terminate, does not repeat. An irrational number cannot be written as a fraction. A rational number can be written as a fraction. So, I have a couple diagrams here just to kind of sum this up. Here's the first one. Okay, so looking at the bottom here, notice your positive numbers. There's your natural numbers. If you add 0 to it, these would be your whole numbers. Notice you have your integers made out of your negative numbers, 0, and your natural numbers. Rational numbers are made out of integers, which can be anything that can be written as a fraction. A rational number can be written as a fraction. Irrational numbers, decimals, that do not terminate or repeat. And all of them are included in the real numbers. All of them fall within the real numbers. A couple other diagrams to help you understand it. Notice the set of rational numbers and the set of irrational numbers fall within real numbers. Within rational numbers, you find integers, whole numbers, natural numbers. So natural numbers, whole numbers, and integers are rational numbers. Not every rational number is an integer. Not every integer is a whole number. Not every whole number is a natural number. Every natural number is a real number. Every whole number is a real number. Every integer is a real number. Every rational number is a real number. And all of them are real numbers. These diagrams can help you understand where the numbers fall. Here's another diagram. The natural numbers, 1, 2, 3, and so on. We add 0 to it and it becomes the whole numbers. Add the negatives, they become the integers. All of those are considered rational numbers, along with any other number that can be written as a fraction. All of those are considered real numbers, in addition to any number that's irrational is a real number. Irrational numbers are those numbers that cannot be expressed as a fraction. Irrational numbers cannot be written as a fraction. Rational numbers can be written as a fraction. Cannot be written as a fraction. Okay? So let's just practice a few of the exercises that you're going to see in the homework. Select all the numbers below which are rational. So rational, think, can you write it as a fraction? So 1.6875, you can write that as 1 and 6,875 ten-thousandths. It's a terminating decimal, so yes. Square root 29. Well, the square root of 36 is 6. The square root of 25 is 5. This number is not going to be rational. Negative 9 you can write as negative 9 over 1. That's rational. This number does not terminate. This number is irrational. This number dot 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 irrational. 0.64, if you take the square root of that, you get 0.8, which is equal to 8/10, which is a fraction. It's rational. 27/8 is a fraction, and we know that repeating decimals can be written as fractions. So those are all rational. Select all the numbers below which are irrational. Okay? So we're looking for those numbers, decimals, that go on forever and do not repeat. Okay? This one cuts off, so it's rational. Nope. Negative 27, no. Square root 53. You get 7.280109889. The only reason it looks like it terminates is because there's no more room on the calculator. That's irrational. This is irrational. 0.49 is equal to 0.7. That's not irrational. This is irrational. Repeating decimals are not irrational. Which of the following is or reduces to an integer? Okay, our integers are 0, 1, 2, 3, along with our negatives. Square root 2 is irrational. It is not an integer. Pi is irrational. It is not an integer. 2/7 will not reduce to an integer. 7 divided by 0 does not exist. It's undefined. The square root of negative 1 is imaginary. There's no number multiplied by itself that equals negative 1. 0 is an integer. 2 is an integer. 14 divided by 1 is equal to 14. It's an integer. 743 divided by 100, that's going to stay. That you cannot reduce that to an integer. Which of the following is or reduces to a rational number? So think fraction. Pi will not reduce to a fraction. This is a fraction. 0, you can write that as 0 divided by 11. Yes. 7 divided by 0, 0 on the bottom does not exist. 0 on the bottom you can always throw out. 2/7 is a fraction. Square root 2 is irrational. You cannot write it as a fraction. Which of the following is or reduces to an irrational number? 3.14, don't be confused by that. That's an estimate of pi, but it terminates. So pi is what you're going to want to circle there for the irrational. Which of the following is or reduces to an integer? 28 divided by 1 is 28. That's an integer. 0 is an integer. 4 is an integer. 11 divided by 0 we know does not exist. 4/11 is a fraction. Pi is irrational. Square root 2 is irrational. 387 over 50 is rational, but it's not an integer. Square root negative 1 is an imaginary number. We haven't talked about those. Which of the following is or reduces to a rational number? It can be written as a fraction. 4/11 is a fraction. 387 over 50 is a fraction. Square root 2 is irrational. You can't write it as a fraction. Pi can't be written as a fraction. 0, you can write that as 0 over 15. 11 divided by 0 we know does not exist because 0 is on the bottom. We're looking for an irrational number here. Which of the following is or reduces to an irrational number? It's pi again. Select all sets that square root 12 belongs to. Well, if you take the square root of 12, you may already know this. You get 3.464101615, and it's going on forever. It's not repeating, it's not terminating. So this is irrational, but it is a real number as well. If you think about those diagrams, irrational numbers do fall within the real numbers. Give a number which is rational, but not an integer. If you enter a decimal number, do not enter more than 8 decimal places. Remember, rational, think fraction, so just name a fraction. Any fraction. -7/8, 15/18. I don't know why I chose that. That's not even reduce. -3/4, 5/7. All you have to do is put a fraction in there. But if you choose a decimal, you can. Just make sure it terminates. Well, obviously, we'll have to terminate. I would just put a fraction in. In which set of numbers would you find the number 28? Well, you know 28's a natural number. It's a whole number. It's an integer. You can write it as a fraction because you can write it as 28 over 1. It's not irrational, but it is real. Now be careful here. In order for a number to repeat, you need to see the bar over it. This is not a natural number. It's not a whole number. It's not an integer. It's not rational because it's not a terminating decimal and it's not a repeating decimal. So it's irrational, but it is a real number. .32, this is a terminating decimal. We could write it as 5 32/100. It can be written as a fraction. We know it's rational. It's not an integer. It's not a whole number. It's not a natural number. It's a real rational number. It's a real number and a rational number. And I believe that's the last one I have. So you can go ahead and try the exercises on your own. I hope this helped you out.